Students, welcome to s.mathguru classes. So our main discussion is partial differential equation, method of Lagrange multipliers of partial differential equation. First order partial differential equation, we solve some problems. Next we consider remaining problems. Solve the differential equation x square del z del x, y square del z del y equal to x plus y into z. Solution: the auxiliary equations are dx by x square, dy by y square, dz by x plus y into z. We consider this. Now first we consider these first two pairs. Now first two members we consider dx by x square, dy by y square. We integrate both sides, we get dy by y square, this one. But we know this formula from lower class, dx by x to the power m equal to minus 1 by m minus 1 x to the power m minus 1 plus c. We know this. So, and m is 2 minus 1, 1. Ultimately, we get minus 1 by x minus 1 by y plus c. This implies minus 1 by x plus 1 by y equal to c. Multiplying both sides by minus sign, then 1 by x minus 1 by y equal to minus c. This implies 1 by x minus 1 by y equal to, we consider c1, minus c equal to c1 we consider. First we get this. Next, using 1 by x, 1 by y, 1 by z as multipliers, minus 1 by z, this one, as multipliers, we get each fractions this is dx by x, dy by y minus dz by z, and this will be 1 by x into x square, 1 by y into y square minus 1 by z into x plus y into z. This implies dx by x, dy by y, dz by z, x plus y minus x minus y. This is x plus y, this one 0, and dx by x, dy by y minus dz by z. We get this. Therefore, finally we get dx by x plus dy by y minus dz by z equal to 0. If we integrate dx by x, integration dy by y, integration dz by z equal to 0. This is log x, log y minus log z equal to log c2. We get this one. This is log xy minus log z equal to log c2, and this is log xy by z equal to log c2, and xy by z equal to c2. We get these two, this one and this one are answer. Therefore, the required solution is f of 1 by x minus 1 by y comma xy by z equal to 0, and this is our final answer. Very easy solution, very nice solution. Consider this problem. Find the general solution of x dz del z del x plus y del z del y plus t del z del t equal to x y t. Now solution, the auxiliary equations are dx by x, dy by y, dt by t, dz by xy t. This is number 1 we consider. First we consider this first pair, dx by x, dy by y. We integrate this. This is log x, log y, log c1. This is log x minus log y, log c1, log x by y equal to log c1, and x by y equal to c1. So we get, therefore we get x by y equal to c1. We get this. Next we consider second pair. Again dy by y, dt by t. We integrate this, dt by t, dy by dy. We can intercept this one also. This is log t, log y plus log c2, and this will be log t minus log y equal to log c2, and in logarithm minus means division, log t by y equal to log c2 and t by y equal to c2. We get another equation. And finally consider this last one. We multiplying both sides by xyt, multiplying the equation 1 by xyt. We get, if we multiplying by xyt, we get dz equal to xyt. If we multiply xyt, then x is cancelled, we get yt. yt dx by 1. This equal to this is xt dy. This is xy dt by 1. We get this one. Now This implies this equal to, if we write dz, this is 1 plus 1 plus 1 yt dx plus xt dy xy dt. This will be, we integrate this, dz equal to, this is 3 and this one d xy t. We get this. Integrate this, integration dz 1 by 3 integration d xy t. So this is z 1 by 3 xy t plus c3 and z minus 1 by 3 xy t equal to c3. Therefore, the required solution is z minus 1 by 3 xy t equal to f of x by y plus phi of t by y. So we express in this way, z minus, we have three equations, this equation, this equation and this equation. So this will be z minus 1 by 3 xy t f of x by y and this is t by y. We get, this is the final solution of the given equation. Next we consider another problem. Solve y plus z into p minus x plus z into q equal to x minus y. Now solution, the auxiliary equations are dx by y plus z, dy by minus x plus z and dz by x minus y. This, because we know this formula, pp plus qq equal to r, then auxiliary equations is dx by p, dy by q, dz by r. So capital P is denominator, capital Q and this. So P, this is dx by p, dy by q, dz by r. This is our capital P, this one capital Q and this one r. So this is our auxiliary equation. Using 1 1 1 as multipliers, we get each fraction equal to 1 dx plus 1 dy plus 1 dz. This is y plus z minus x minus z plus x minus y. This equal to dx plus dy plus dz and this is y cancel, z cancel, x cancel, this is 0. Therefore what we get, dx plus dy plus dz equal to 0. If we integrate both sides, dx integration dy integration dz equal to 0. If we integrate, then we get finally x plus y plus z equal to c1. Integration dx means y, dx means x, dy means y, dz means z. This is constant C1. We get the first equation. Again using x, y, z as multipliers, we get each fraction again using x, y minus z as multipliers, we get each fraction. That means we multiplying this one x dx by x into y plus z equal to y dy by minus y into x plus z minus z dz by minus z x minus y. This one we adding this plus, this is plus, we get this, each fraction is this, and this equal to x dx y dy, this is minus z dz, this is xy plus xz minus xy minus yz minus zx plus yz, this one. xy cancel, xz cancel, and yz cancel. So we get denominator is 0. X dx plus y dy minus z dz. Therefore, what we get, x dx plus y dy minus z dz equal to 0. Now we integrate this. Integration x dx plus integration y dy minus z dz equal to 0. This is x square by 2 y square by 2 minus z square by 2 c2 by 2. Then multiplying both sides by 2, x square y square minus z square equal to c2. We get two solution. This one x plus y plus z equal to c1 and x square plus y square minus z square is c2. Therefore, the required solution is f of x plus y plus z comma x square plus y square minus z square equal to 0, and this is the final answer. Very easy solution, very interesting, but these are most important for engineering courses and BSc Maths major, MSc also. These are most important and very easy also. Thank you.